Okay, let's just jump right in. What if I told you that every single time you talk to an AI, you're not really using language at all? Turns out you're actually using a secret kind of math.
You know that feeling, right? You type a sentence into an AI and it just gets it. It feels like it's reading, like it truly understands your words. But here's the thing, that feeling, it's a really, really convincing illusion. What's actually happening under the hood is something else entirely. And honestly, it's way more interesting.
Because, see, the machine doesn't care about your words, not in the way we do. It's treating your prompts less like sentences to be read and more like coordinates to be plotted on this huge invisible map. Your words, they're just points in space. So, how do we wrap our heads around this? Well, to really get it, we just need one simple, powerful idea. I want you to imagine all of language as a giant cosmic star map.
And believe it or not, this idea isn't even new. It goes way back to the 1950s. A linguist, J.R. Firth, came up with this brilliant insight. You shall know a word by the company it keeps. And that one single principle, that's the key that unlocks the whole thing. It's what allows a computer to map out language in the first place.
So let's run with that. Think of every single word as a star. Now, a star's identity isn't just about the star itself, right? It's about its position. Is it part of the Big Dipper? Is it in Orion's belt? Its neighborhood defines it. And it's the exact same thing for an AI. The only way it knows what happy means is by seeing where that happy star is located in relation to all the other stars.
Okay, let's make this super concrete. On our star map, words that are related are going to be clustered together. So the star for dog is right next to the star for puppy. They're practically touching. And dog is also pretty close to leash, because they hang out together a lot in sentences. But what about the star for calculator? Ha! That thing is in a completely different galaxy, millions of light years away. It's all about proximity. Proximity is meaning.
All right, so this star map analogy is great, but how does it actually work? How does a computer take this fuzzy idea of the company word keeps and turn it into cold, hard coordinates on a map?
Well, it's actually a surprisingly straightforward process. First up, the computer just counts. It scans a mind-boggling amount of text and literally just counts how many times happy shows up near smile and how many times it pops up next to birthday. Then it creates a simple graph where those context words, smile and birthday, become our axes. From there, it just plots happy based on those counts. And then it does the exact same thing for every other word, like sad.
So this is what that looks like. Here's the raw data. Think of this as the before picture. The computer crunches the numbers and finds, okay, happy appears near smile 10 times and near birthday 8 times. Meanwhile, sad only shows up once near smile and twice near birthday. These numbers right here, these are the raw ingredients for our map. And boom, just like that, those numbers become actual positions on a graph. You can literally see it. Happy is way up there in the top right, while sad is hanging out down in the bottom left. They live in completely different neighborhoods on the map because they keep totally different company. Okay, this is super important because it brings us to the single biggest misunderstanding people have about how this works. It's so easy to look at those coordinates and make one critical mistake. So, here's the mistake. Looking at that number 10 on the smile axis and thinking it means very smiley or has some kind of absolute value. It doesn't at all. That number 10 is completely meaningless on its own. The reality is, a coordinate only has meaning when you compare it to other coordinates. The AI doesn't know what happy is in a vacuum. It only knows what happy means by seeing how far away it is from sad or excited or bored. It's not absolute. It's all relative.
So let's play with this idea for a second. Let's say we add a brand new axis to our map, a third dimension, for the word ice cream. Now, what do you think would happen to the distance between happy and sad? Would they get closer together or move further apart? Just think about that for a moment.
Okay, so now that you've got the complete intuition for how this works, it's time to put the official technical name on it. This entire star map concept we've been talking about, the formal name for it is a vector space model, or VSM. That's it. It's just a model that represents words in a geometric space using vectors. It's the engine that lets a computer use the clean, predictable rules of math to figure out something as messy and human as meaning. So next time you hear an engineer talk about a vector, don't let the jargon intimidate you. A vector is just the fancy word for that list of numbers, like 10,8 for our word happy. That acts as the word's address on the map.
It's really just a coordinate. It's a location. That's all it is.
All right, so let's bring this all home. What are the big takeaways here? How does knowing about the star map actually help you understand the AI you're using every day?
Okay, there are really three big things to remember. First, to an AI, words are just addresses. Meaning is a physical location on a map. Second, our little map only had 2 dimensions, right? Real AIs use maps with thousands of dimensions, or axes, to capture all the subtle shades of meaning. And third, this is the secret sauce behind all those recommendations. When an AI suggests a new song or a product, or even just the next word in your sentence, it's not thinking. It's just doing math to find the nearest neighbor on its map.
And with this new toolkit, you can now solve a classic AI puzzle. Why do AI models sometimes get so confused by a word with 2 different meanings, like the word bank? Well, if you think about our star map, you know the answer. The AI is trying to plot a single star, bank, in 2 completely different constellations at the exact same time. One is over there with river and shore, and the other is way over here with money and finance.
So we've built the map. We've plotted all the stars. But that leaves us with one last, really fascinating question. How does an AI actually measure the distance between any 2 of those stars to figure out just how similar they are? That is the next piece of the puzzle.